Right. In the last class, we started the recursion and recurrence relation. For the factorial of n, we are already completed. Right. In that problem, if you felt that, sir, somewhere we didn't get and all, that is starting of the recursion, some small doubts may be there. Right. Now, best thing is going to be whatever happened, right. Small doubt also there. Afterwards, you can go back and you can revise again. Right. Now, see this problem. Right. I think 3 more problems are there pending. Right. You complete those also. Afterwards, if you have small doubt also, just see all the 4 problems again and again. Mostly you are comfortable. Right. So, see the second problem. This is the second problem. Write recursive program and recurrence relation to find multiplication of m comma n, where m comma n greater than or equal to 1. That is the given problem. To this one, recursive program you should write and recurrence relation also you should write. Right. So, let's start this. Right, I am starting recursive program and recurrence relation, both you have to write, where m comma n greater than or equal to 1. That is the given problem. Let's see. Many ways are there. Try to remember this one. Right, different people will write different logics. Right, best possible whatever you are thinking that point of time. Right, please write that. Don't think about the someone is written like that, someone is written like this one. Right. So before exam, just to do enough practice. Before exam, if someone said right, this algorithm best. Someone said this algorithm better, please go through it. Right? Best algorithm find out by yourself. Before exam only do all the things. Right? Now to this one, to find out the multiplication of m comma n, right? One logic I will write. You know that logic also, right? You know that logic also, I will write that. Next one, multiplication of m comma you have to do. Some people are asking, sir, what is the meaning of this problem? Let me repeat now. Right? Suppose that m comma n, right? 5 comma 7 is given. M is 5. N is 7, 5 comma 7 is given, 5 7s 35, answer should be 35. To do this, right, to do this one, if I give 5 comma 7, output should be 35, right. So, for that purpose, you should write the recursive program. I am not asking you write any program. To do that story, you should write recursive program, right, please be careful. Many logics are there, I am writing one logic. Right, I am writing one logic. And one more thing, try to remember, depending upon logic, time complexity will change, space complexity will change. Some people are thinking that multiplication of m comma n always same time complexity. No, logic changes, time will change, space also will change. Program will decide, your logic will decide how much time, how much space. Depending upon how you write, right, times and space will be, little bit differences will be there. Please be careful. I am starting now. So, to do multiplication of m comma n, recursive program I am writing. So, see the one of the logic. This is the logic I am implementing. What is that logic? See this one. M into n I want to do, which is equal to, see the logic now. Right, m into n is nothing but logic is like this one. See, adding m n times. Adding m n time. This is the one logic. Adding m n time, which is nothing but like this one. Adding m n times, m plus and so on. Right? N time. Yeah, m, which is going to be n times. This is the logic which I want to implement. Please be careful, depending upon logic, time complexity will change, space complexity will change. To this problem, I am implementing this logic. And some more people are asking me, sir, can I do the same thing in some other way? Different ways are there. One more way, right? Adding n, m times. Adding n, m time, you know very well. M into n into m, both will give same answer. Multiplication will satisfy, right? Commutative property. M times n, adding m n time or adding n m time, both will be same, but because of logic change, right, finally output will be similar, right, because of logic change, right, time complexity will change, please be careful. This logic I am writing. To this particular problem, recursive program I should write. If you want to write the recursive program, you have to find out the logic, what logic you are going to implement. Many logics may be there. And one more, right? See this one, recursion means what? Doing same thing again and again. If you want, you can see in this problem. In this logic, what is the answer? M plus, same thing I am doing. Whenever someone will say from now onwards, write the recursive program to this problem. What is the answer? You have to find out one logic. The logic is going to be adding m n times. Right? This is the logic I written also. right? Depending upon logic, time complexity, space complexity will differ, right? Please be careful. One logic I written. Now listen from now onwards, if anyone asks you, write the recursive program to this problem. What is the answer? You have to find out one logic way doing same thing again and again. If anyone asks you from today onwards, write the recursive program for a particular problem, right? Then to solve that problem, before going to start, think like this one. Is there any logic by doing the same thing again and again, right? I will get the answer. Just think like that, right? So some people are asking, sir, where are you doing here? I am doing here also. If you want, you can check. See this one, m plus, m plus, m plus, m plus, right? I think same thing I am doing again and again. Recursion means that kind of idea you should get. From today onwards, if anyone asks you, write the recursive program to this problem, what you have to do? Find one logic. By repeating that one many times, you should get the answer. Suppose if you are unable to find out, right, please think about it. Don't start blindly, whatever way you want, right? Please plan it, okay, right? So multiplication of m comma n, right? So I think multiplication is nothing but repetitive addition. So I done the same. M plus n time. Some people are asking, why can't reverse? What is the meaning? N plus, that is also okay. One logic you think about. If you think that comparing these two, right, first logic better, go first logic. Second logic better, then go to the second logic. If you think that both are okay, take any one. Right, like that. I maybe said two logics to solve this problem. There may be so many ways. I am really saying to you, many ways are there. Different people will think different ways. If at all one way, two way, it is not like that, right? Maybe you know two, maybe I know three, maybe your friend know one, right? Some other person know five, right? Depending upon person and all. You cannot say for any problem only one logic is there. If you study more, if you prepare very well, many logics you will find out. In GATE examination, if anyone asks you, right, better logic you can give. Please be careful. As of now, maybe you know one logic. After listening my lecture, right, maybe two logics you know. Right, if at all some more, if you keep on discussing with your friends and all, if you keep on studying some books and all, you may find out some more logics. Right, just grasp the information as much as possible. It will be useful some point of time. As a CSE person, algorithm subject, try to get as much information as possible. Okay, anyhow, let's start now. What is our goal? Multiplication of m comma n, recursive program, recurrence relation we should write. I written the logic also, right? If you are okay with this logic, see the example, right? After completion of the logic is over, see the example. One example I want to give, see the example. See this one, multiplication of m comma n, anything is fine, m comma n is in the 2 comma 5. Multiplication of m comma n 2 comma 5 is equal to, what is the answer? Recursion you know very well. What is the answer? 2 plus, right? Adding 2 5 times, 2 plus multiplication of, right, 2 comma 4 times you have to do. So actually 5 times, 1 time over, right? I think 4 more times you have to do. If you know this answer, just come back and add 2 plus, then answer you will get. Suppose if you don't know this also, complete the recursion similar way. 2 plus multiplication of, right, 2 comma 3. Next one, 2 plus multiplication of 2 comma 2. Next one, 2 plus multiplication of 2 comma 1. Right, like that continue. Some people are asking, sir, you are keep on going. You know very well. Recursion means keep on go. Right, do the same thing again until termination condition will come. Some people are asking, sir, what is the meaning of termination condition? Termination condition is nothing but the place, right, you know. Right, the function which you know until will come, right, then continue. Whenever your required thing is came, the thing which you know came, then stop it. But I am repeating once again. Recursion means continue until termination condition will come. Termination condition is that one which you know that. Right, that is the meaning of termination condition. Can you help me now? Multiplication of 2 comma 1, every one. What is the answer? Multiplication of 2 comma 1 is going to be, right, 2 into 1 is 2 only. 2 into 1 is 2 only. If you know this one, right, you can stop here. If you think that, sir, I don't know that also, if you think like that, then you can go further. What is the answer? Multiplication of 2 comma 0. Multiplication of 2 comma 0. Right? 2 plus multiplication of 2 comma 0. I think here you can stop. Everyone know. Whenever you are doing multiplication of two number, if any number is 0, right? If one number is 0, answer is 0. I want to multiply m comma n, m 0, answer is 0, n 0, answer is 0, if both 0, then answer is 0. You know very well multiplication, this is the minimum thing which people should know. Yet listen, continue until the thing which you know will come. So if you know multiplication of 2 into 1 is 2, then stop it. If you don't know, then go next round, right? Multiplication of 2 comma 0, any one is 0, answer is 0. You know very well. At least something you should know. Now one more thing, what is the greatest advantage with the recursion? Greatest advantage with the recursion is going to be multiplication of 2 comma 5, you can give answer if you know multiplication of 2 comma 0. Right, using small problem answers, right, getting the bigger problem answer, that is called as recursion, right. I am solving the bigger one, 2 comma 5 in terms of all. And one more thing I want to say to you, to do this one, this is required, to do this one, this is required. If you don't know all these things, it's okay, but at least you should know something. Minimum termination condition you should know. Continue until termination condition will come. Yes, I think 2 comma 0, what is the answer 2 comma 0 value? Let me check this one, 2 comma 0 value, right? This is going to be 0. What is the 2 plus 2? 2 plus 0, 2. This is going to be 2. 2 plus 0, it is going to be 2. What is the 2 plus 2? 4. This is going to be 4. What is the 2 plus 4? 6. This is going to be 6. Right? What is the 2 plus 6? Right? 8. This is going to be 8. What is the 2 plus 8? Right? 10. Right? 10. Multiplication of m comma n, answer is going, multiplication of 2 comma 5 is 10. You know answer is 10. And one more. The thing which is coming back, see this one. I went until down, right? I am going back. Going back is nothing but pop operation. Coming is nothing but push operation. Right? Can you help me now? Going back, what is the meaning? Pop operation. Coming is nothing but push operation. Can you help me now? What is the meaning of coming? Coming is nothing but calling. Every function call, push. Function call, push, and so on. Function over, pop. You know very well, that's what happened in the previous problem. This problem same. Just I think little bit of logic is different. Small difference of logic. I hope everyone fine with this particular story. Right? What is the termination condition? Multiplication of m comma n, answer is 0 if any one is 0. This is the example. Right? See this one. Whatever logic I written, right? To get the clarity. Right? I written the one example also. If anyone thinking that by seeing that logic we are okay, directly you can go to the program. By seeing that logic, small doubt also there. Take one numerical example, check like this. Right? Fine. I am thinking that you are little bit okay. Right? Let's go to the problem. Right? Let's go to the program. Right? Let's go to the program. I am doing the program very simple. See this one, multiplication of m comma n. Multiplication of m comma n. What is the first step? Every recursive program contains 2 parts. What is the answer? Right? When to stop and when to continue. Everyone in the program, when to stop will come. Termination condition. What is the reason? As soon as I started, I can stop. Then why you continue further? First to ask, can I stop or not? Yes, then stop. Suppose stopping not possible, then continue further. Only 2 cases. Stopping or continuing. Don't continue first to ask, can I stop or not? Starting itself, stopping possible. Why you go further? Right? So ask the first step. Right? Is it termination condition? True. Then stop. Not termination. Then continue further. I am starting now. See this one? Multiplication of m comma n. What is the answer? Adding m n time. What is the termination condition? This is the answer. See this one? If m is equal to 0 or n is equal to 0, then return 0. Any one is 0, then return 0. That is the termination condition, everyone know. Now see the answer, else part. It is the major one, else part. Suppose it is fail, right? The else part means what? If condition fail, then I will come to the else part. If condition fail, then what is the answer? Everyone know. What is the answer? M plus multiplication of m comma n minus 1. Right? So whenever it is fail, adding m n time, one time add, continue further by recursion. Right? After getting this one, that will be added to here. Final answer you can return this. Right? End of this particular program. Every recursive program contains 2 parts. If condition, else condition. This is the stopping point. This is the continuation purpose. Actually, m times n. Right? See, for everyone, what is the meaning of what is the logic I am implementing? Adding m n times. Adding m n times. Sorry for that. Adding m n time. Everyone know this one. That is the logic, right? Same. Adding m n time. One time I added. Remaining thing called recursion. You will take care. Some people are asking, sir, how it will be computed, right? In the recursion, internally they will call. This person will call this one. This will call further. Same thing. Whatever way calling happen, right? Like that it will happen, right? Please be careful. It is a recursive program. Next one, some people are asking, recursive program, it's okay. What about recurrence relation, right? Everyone, a recursive program is available, recurrence relation also available. Same thing you write, right? Same thing you write in the form of a mathematical relation. Let me write now. First one, first place. Second one, second place, right? So I am writing now. I am writing. See this one. See this one. Multiplication of m comma n is equal to first one first place, second one second place. What is the answer? Multiplication of m comma n. Answer. What is the answer? Answer is going to be 0 if m 0 or n 0. Just write in the form of mathematics, right? If m is 0 or n is 0, answer is 0. Otherwise, second part, what is the answer? M plus multiplication of m comma n minus 1. When it is? If m comma n greater than 0. Any one is greater than 0, this is the story. Same recursive program, right, in the form of a, right, mathematical relation, that is called as recurrence relation. It is a recurrence relation. It is a recursive program. It is a recursive program, right? Just see, for the given problem, many logics may be there. If you know many logics, which logic you feel better? Which logic you feel that, right? Better one among all, right? Take that logic, right? Next one, that logic if not that much clear, take one example and try. If at all example is clear, then write the program for that. As a CSE person, not only logic you are clear, or not only that, you should write the program also. At the end of the day, program matters. As a CSE person, whatever you know, you have to keep inside the system. If you are unable to keep inside the system, even though you know, no use. Right? First of all, logic you should be clear. Next one, programming also you should be clear. Right? Next one, analysis also you should be clear. Right? These are the things which you have to take care. First, concentrate algorithm subject purpose is, right, logic improving, right, followed by writing the code also. That logic, right, in the form of your program. These two things you have to do. First, majorly logic. If you are really okay, logic, right? As a CSE person, keep in the system also, means write program. Afterwards, right? Do you know clearly what is going on? That is called analysis and all, right? We'll see anyhow. For the given problem, recursive program I written, recurrence relation also I written, right? Fine. So purpose for our discussion is going to be recursive program writing, recurrence relation writing, right? Please be careful. And one more thing I want to ask you, can you help, whenever this story is going on, how many times recursion is going on? See this one, m, right, adding m n times, right, n time you are keep on calling, how many time? N time, you are calling n time, right? This recursive program time complexity is going to be how many time? N time. Everyone now, recursion loop is same, loop also doing same thing again and again, right? Recursion also doing same thing again and again. Recursion, loop, both will be similar, right? Recursion also doing same thing again and again, loop also doing same thing again and again. Can you help, in this program, what is the answer? Adding m, n times you are doing, see this one, n times you are doing. So time complexity means how many times? Time complexity of, right, right, what is the answer? Multiplication of m comma n. For this logic is going to be, what is the answer? Big O of m or n. How many time? N time. Time complexity of multiplication of m comma n, right? Big O of n, right? Please be careful. Right? Big O of n. Right? That is the time complexity. Can you help me one small line now? What is the space complexity? Let me check here. Space complexity. What is the answer? Input plus extra. Can you help me? What is the input? M comma n, 2 integers. Every integer is 2 bytes, 2 integer 4 bytes. Can you say what is the extra? Right, extra, what is the answer? Extra means everyone now. Whenever recursive program is going on, stack space you are taking. Whenever recursive program is going, stack space you are taking. Can you see in that stack, who is first pushed? This one. Next one this, next one is this, next one is this, next one is this, next one. How many times? What is the answer? I think adding m n times. How many? n times. See this one, n value 5, afterwards 4, afterwards 3, afterwards 2, afterwards 1, until here 5, including this. See, these all will push inside stack. And one more thing, recursive program behavior you can mold in the form of a tree, right? See this one, E will call this one, E will call this one. Can you say who called first? Multiplication of 2 comma 5 called who? 2 comma 4. Next 2 comma 3. Next 2 comma 2. Next 2 comma 1. Next 2 comma 0. Right? Like that. It is a tree. Recursion, calling like this. Right? It is a recursive tree. Some people are asking me, right, how it is a tree? Everyone, it is unary tree. Every recursive program behavior you can mold in the form of a tree, because you know every time doing same thing, right, tree will come. It is unary tree. Can you help me one small line? From today onwards, if anyone asks you, to this recursive program stack space how much? What is the answer? In that recursive tree, how many levels are there? From today onwards, if anyone asks you, recursive program is there. In that recursive program, how much stack space you will take? What is the answer? In that recursive program, right? Definitely one recursive tree will come. Every recursive program behavior we can mold in the form of a tree, right? So in that recursive tree, how many levels are there? Count. What is the answer? M comma n, n value 5. How many levels there? 1, 2, 3, 4, 5, 6 levels there. So stack space is going to be, right, recursive tree number of levels required. Right? So which will goes to n plus 1, right? Assume that every level, right? Every level 1 byte required. Assume every level is pushed in the stack. First function call, second function call, third function call, everyone will be pushed inside the stack, right? N plus 1 levels are there, n plus 1 bytes. So input is going to be 4 bytes, extra is going to be n plus 1 byte, overall, forget about small constant. What is the answer? Big O of n. Right? Time complexity to this problem is n, right? Stack, right? Space complexity, input plus extra is going to be big O of n. Space complexity is nothing but whenever your program is running in the main memory, right? How much space it will take. The total amount of space it will take while program is running is known as space complexity. So input plus extra you have to add, right? Normally, next one, see this one. Space complexity means total, that's okay. Right? If they ask you extra, give extra only. If they ask you extra, then give extra only. If they ask you space complexity, then give total. Normally, and one more thing I want to ask you, when you are comparing two algorithms, right, extra space only will compare, because both the algorithms contain input. To solve the problem, two algorithms I have. Right? When you are comparing space, right, compare only extra, because input is anyhow, both are same. Both algorithms will take same input, because, right, same problem you are solving. While comparing two algorithms, compare the extra space only. But space complexity means total space. Right? I am repeating the space complexity definition. Right? Right? The amount of space program will take while running is known as space complexity. Right? Fine. Input plus extra, both you have to calculate. Right? Fine. Right? I am thinking that it's fine. Right? To this problem if you observe, right, time is going to be n, space is going to be n bytes, extra is this much, right, input is this much, right? And one more, some people are thinking that time complexity, space complexity same, no relation at all. No relation. If at all both are same, then why we are studying two times, time complexity, space complexity? In this problem maybe both are same. Next problem may be same, previous problem may be same, it doesn't mean that both are same. Right? I'm thinking that you got the second problem. One problem is factorial, right? We done already. One more problem is, right, multiplication of m comma n. Right? So I think I written, see this one, in this problem, three things I done. Recursive, right? See this one, to this one, logic I written, to that logic I took one example and I explained. Recursive program I written. For every recursive program, recurrence relation also possible, right? Next one. After writing the recursive program and recurrence relation, just I am analyzing also. Actually, here no need to analyze. What is our goal in this problem? Writing recursive program, recurrence relation. Only that is our goal. But I am doing time complexity finding also, space complexity finding also. Really not required. But one thing I want to say to you, recursive program and loop both are same. Loop is how many time? Recursive program also, right, same story. This is also many times repeating. Loop also many times. Time complexity means loop only, indirectly, directly. When you say loop, what does it mean? From today onwards, if anyone asks you, what is the meaning of loop? Right? If anyone say to you, loop is nothing but recursion. Loop is nothing but doing same thing again and again. Both will be similar. Now, can you help me now? Can you help me now? Recursive program, time complexity finding. I explained, right? If anyone thinking that, it is a very, very important one. If anyone thinking that recursive program, time complexity finding, sir, I am feeling little bit difficulty and all. If anyone thinking, right, don't think that much. The reason is, right, recursive program, time complexity finding purpose, one special procedure is there. This is only for namesake I am saying, just rough idea, right? You no need to consider this also. How, right? I think n times you are doing time complexity n. Complicated recursive programs are there, right? Finding time complexity very difficult if you do like that. There is one standard procedure is there, right? After correct time I will say that procedure also. Recursive program time complexity finding, right? There is one standard procedure, right? Maybe in the next class it will come. Roughly I am giving. After completion of, right, whenever I bring standard procedure, right, using that procedure, you can try time complexity finding for all recursive program. Roughly I am giving now, right? How many times you are repeating? N time. Now, can you help me now? Recursive programs, right, extra space, how will you calculate? Recursive program extra space based on, right, in that recursive tree, how many levels are there? Recursive program extra space is based on, in that recursive program, how many levels are there? I think in this recursive program, what is the answer? N plus 1 levels are there. I think extra space becomes n plus 1. I'm slowly introducing one by one. In the previous problem, I am unable to say all these things to you. Comparing previous problem, little bit you improved now. Next one, I think after 2 problems are over, more clarity will get. But one thing I want to say to you, in all these 4 recursive program, right, time complexity roughly I am explaining. Right, roughly manually I am explaining. There is one nice procedure. If you do manually, what is the problem? You may do small mistake. If you go to the one standard procedure, right, that standard procedure, you never do wrong also. But it is better to say both, right? So, but you have to follow in every examination, right, standard approach, right? What is that approach? Afterwards we will see. Can you help me? Time complex how much? Roughly I am saying n times you are repeating, right? N times you are repeating, so n time. Right? What about extra stack space? Right? I think recursive tree contain n plus 1 levels, n plus 1. Now one more thing I want to ask you. What is the standard procedure to find out the recursive program time complexity? We will see afterwards. Guarantee I will explain. There is one nice procedure is there. Right? You will see that. I think it is the second program. Right? Let's go to the one more problem. Until now 2 problems I said for the recursion and recurrence relation. Right, it is the third problem. 1 or 2 small doubts are there in the previous one. Mostly I will clarify here. Right? Let's see. Right? Let's start. To find out the nth Fibonacci number, we should write recursive program and recurrence relation. So we are doing now. So let's see. See the answer now. N Fibonacci of n. N and Fibonacci of n. We should find out the, right? So let's see the Fibonacci series. Many people know. Let me remind you once. 0, 1, 2, 3, right. See this one. N, I think this is the n. Right? It is the Fibonacci of n. Can you help me one small line now? How to find out, it is the Fibonacci of n. How to find out Fibonacci of 5? What is the Fibonacci of 5 value? If n is 5, what is the Fibonacci of 5 value? What is the answer? Fibonacci of 5 value based on, right? Fibonacci of 4 value plus Fibonacci of 3 value. Fibonacci of 5 value if I want, if anyone remembered, this is the Fibonacci behavior, you know. If n value 5, what is the, right? If n value 5, what is the Fibonacci of 5? Fibonacci of 5 is equal to Fibonacci of 4 plus Fibonacci of 3. Means Fibonacci of any number is completely based on previous 2 numbers. Previous 2 things if you add, you will get the next number. That is called Fibonacci series. Right? Next one, in the similar way, how to find out Fibonacci of 2? It is the 2. It is the 2. Fibonacci of 2, how to find out? Right? Previous 2 numbers you add. Then you will get the Fibonacci of 2. Right? Now some people are asking, previous two numbers if I add, I will get the next number, that is the Fibonacci series, that is fine. But how to get the first two? How to get first two? Try to remember, every recursive program should have termination condition. What is the answer? For Fibonacci, two terminations. Fibonacci of 0, Fibonacci of 1, you should know. Then only Fibonacci series will continue further. Fibonacci of first two things will be given by user only. You can give whatever way you want. Based on first two, remaining will come. Right? Fibonacci series having two termination, Fibonacci of 0, Fibonacci of 1. You can give whatever you want, normally people will give. Fibonacci of 0 is 0, Fibonacci of 1 is 1. Right? Let me give like that. Fibonacci of 0 is 0, Fibonacci of 1 is 1. Right? Now see what about remaining? Fibonacci of 2 is equal to sum of previous 2. So 1 will come. Fibonacci of 3, previous 2. Fibonacci of 4, previous 2. Fibonacci of 5, 5. Fibonacci of 6, 8. Fibonacci of 7, 13. Fibonacci of 8, 21. Fibonacci of 9, 34. Fibonacci of 10, 55. Like that. Right? So Fibonacci of any number is equal to sum of previous two terms. Right? Like this. This is the Fibonacci series. Now from today onwards, if anyone asks you how to find out Fibonacci of 50, if from today onwards someone asking you what is the Fibonacci of 50 value, supposing that someone said to you Fibonacci of 50 how much, if they ask you like that, then what will you say? Fibonacci of 50 value, if they are asking, if you know, directly you say. If you don't know, simple way of escaping. Fibonacci of 50 is equal to Fibonacci of 49 plus Fibonacci of 48. If they ask you what is the Fibonacci of 48, say same way. Fibonacci of 47 plus Fibonacci of 46, like that. Right? If you really comfortable whatever happened until now, now you say what is the Fibonacci of n value roughly? What is the answer? Fibonacci of n is equal to Fibonacci of n minus 1 plus Fibonacci of n minus 2. Previous two things you add, you will get it. Right? Somewhere in one of the book I studied this line. See this one? See correctly this line also. Fibonacci soup is equal to, like sweet corn soup, like tomato soup, right? Like that. Fibonacci soup is equal to, see this one? Fibonacci soup is equal to yesterday's soup plus day before yesterday's soup. Fibonacci soup is equal to yesterday's soup plus day before yesterday's soup. Means indirectly, directly they want to say that previous two things you mix them, then you will get the next one. That they kept one name also, Fibonacci soup, which is equal to, they want to say that what is the meaning of Fibonacci? Previous two things you mix, you will get the next one. Right? Please remember the reason why I said this one is, right? You will remember easily. That is the only reason for that. So Fibonacci series everyone know, right? From today, no need to by heart also. Fibonacci of any number, previous two numbers add. What about first two numbers, right? First two numbers user can give whatever he want because they are termination. Based on that, remaining story will come. So people normally will give Fibonacci of 0 is 0, Fibonacci of 1 is 1. Right? This is the entire story, everyone know. If anyone thinking that, sir, I am comfortable, Fibonacci series I am comfortable, please last question I want to ask you. How to find out Fibonacci of 100, Fibonacci of 99 plus Fibonacci of 98. Termination, Fibonacci of 0 is 0, Fibonacci of 1 is 1. Are you comfortable? If you really comfortable, right? As a CSE person, not only saying I am comfortable, logic and all, you should write program. If you say logic I am comfortable, I am not able to write the program. If anyone say like that, I think you are not clear. You are not CSE person. Please be careful. Right? If you are really right CSE person, first thing should be logic you should find out. After logic finding is over, program you have to write. Please be careful. Program you are unable to write, you stuck somewhere, means maybe logic is not clear. Maybe you are not a good programmer. Right? Please practice both the thing. Logic also, logical thinking also you have to improve. Right? Coding part also you have to improve. These two things combined there. Right? I think wherever you go, you will get the job. Right? Fine. Let me write the program. Whatever we are talking until now. Right? For that, let me write the program. I am writing the program. See this? See everyone now, it is very simple. Recursive program writing is very simple, everyone now. See, Fibonacci of n. Right, inside. What is the answer? It is having one termination or two termination, right? So two terminations are there. So I am writing now. See this one. I am writing if, see this one, if n is equal to 0 or n is equal to 1, means Fibonacci of 0, Fibonacci of 1, right? Any one, then answer is going to be return, right? N. If n is 0, then return 0. If n is 1, return 1. What is there in that? If you want, you can write this entire story in, write 3 lines also. Yeah, write 4 lines also. If n 0, right? N 0, return 0. If n 1, return 1. Like that also you can write. Combinedly, I return the meaning. Combinedly, I return. Meaning wise same. You write whatever way you want. Can you say Fibonacci of n? What is the inside? As soon as you enter inside, termination condition check. What is that one? If n 0, return 0. N is 1, return 1. Right? If you compress it like this, it will come. If n is equal to 0 or 1, return n. I am not returning 1. I am not returning 0. I am returning n. If n 0, return 0. If n 1, return 1. Right? Like that. That's okay. Termination okay. Let's go to the major part else. What is the meaning? Suppose it is fail. What is the meaning? I think not termination. Other than that. What is the answer? Other than this everyone know. Fibonacci of n minus 1 plus Fibonacci of n minus 2. Right? Return. After getting both the things, right? Add both of them, you will get the final answer. Return it. It is the recursive program for that. I explained clearly example. Afterwards, I went for recursive program. It is the recursive program. Let's go to the recurrence relation. Everyone know recurrence relation writing is very simple. Recurrence relation. First one, second one. See this one. Fibonacci of n is equal to. What is the answer? Fibonacci of n is equal to, answer is n. If n is equal to 0 or n is equal to 1. Otherwise, what is the answer? F of n minus 1 plus f of n minus 2. If n is greater than, right? If n is greater than 1. If n is greater than 1, this is the story. So I am thinking that you are really comfortable. Program is okay, right? And recurrence relation also okay. Next one. Some people are asking, sir, can you analyze this recursive program? Last time I want to ask you, recursive program, right? How to find out the space complexity? Recursive program, how to find out space complexity? What is the answer? Input plus extra, it's okay, right? Input you can find out, that's fine. What is the extra? How will you find out extra? If you want to find out extra recursive program, right? Recursive tree length you have to find out. What is the height of the recursive tree? You have to find out. Time complexity, how to find out. Recursive program time complexity, how to find out. As I mentioned to you, afterwards one nice procedure will come. Now roughly I will explain. To you. Time complexity of the recursive program, roughly based on, it is not exactly. Time complexity of the recursive program, roughly based on number of function calls. It is not exactly, I am reminding you again and again. Recursive program time complexity roughly based on number of function call. Means how many calls are there? How many calls? Roughly, right? Roughly. But standard procedure is there, we will see afterwards. Again and again I am reminding you so that you don't do one small mistake also. Some people are saying, sir, why don't you say that standard procedure now itself? If I say now itself, right, some students will die also. I want to say now itself, right? I am controlling myself a lot. If I say now itself, some people will die. That is the reason I am not saying. Correct time I will say that story. I am reminding you again. From now onwards, today onwards, if someone asks you, recursive program time complexity, how to find out? What is the answer? One standard procedure, we will see that. Until that time, I am giving some rough diagram. Recursive program time complexity based on, right, number of function calls. Roughly number of function calls. Actual thing we will see afterwards. Right, don't worry. Now, I think one thing is true. Every time this is going to be correct answer. Recursive programs, extra space based on number of levels, not number of function call, number of levels in the recursive tree. Recursive time extra space is based on number of levels in the recursive tree. Recursive program time complexity based on number of function call. Right, that is okay. Now I am doing the rough diagram for this. Let's see. To this program, what is the time, what is the space? I will give rough diagram. Please see this one. Fibonacci of 6. If I want to find out, how to find out Fibonacci of 6? Fibonacci of 6 is based on Fibonacci of 5 and 4. Previous two things you will get Fibonacci of 6. Next one, how to get 5, 4 and 3. How to get 4? What is the answer? 3 and 2. How to get 3? 2 and 1. How to get 2? 1 1 and 0. I think these two are termination, no need to go further, right? This is also already there. 2, 1 and 0. 3, 2 and 1. 2, 1 and 0. 4, 3 and 2. 3, 2 and 1. 2, 1 and 0. 2, 1 and 0. Right, like this. Right, so whatever is happening, right? Fibonacci of 6, listen, Fibonacci of 6 if I call, Fibonacci of 6 if I call, internally this much story. Fibonacci of 6, right, if I call, internally 6 will call 5, 4, 5 will call 4 and 3, 4 will call 3 and 2, 3 will call 2 and 1, 2 will call 1 and 0. Like that everywhere happened, this much story there inside Fibonacci of 6. Some people are thinking that, some students are thinking that Fibonacci of 6 means, right, Fibonacci of 5 plus Fibonacci of 4, previous two things you will add, you will get the next one, but how will you get previous two? Again they will call their previous two, they will call their previous two, like that it is happening, see. And one more interesting question I want to ask you from this problem. Can you, some students are asking, sir, you got one recursive tree, it's okay. Some students are asking, you got one recursive tree, we are okay with that. Every recursive program will generate one recursive tree. That is okay. But now, if you see this diagram, if you see the previous diagram, what is the difference? What is the answer? In the previous diagram, all the recursive trees are unary trees, but here binary tree. See this, binary, 2 people. Here also 2. What is the binary tree definition? Every node contain maximum 2 children, not 2 children. Every node contain maximum 2 children. Maybe 0 child, maybe 1 child, maybe 2, maximum 2 children. In the given tree, everyone contain maximum 2 children, that is going to be binary tree. It is a binary tree. Some students are asking, in the previous problem, unary tree came, but in this problem, binary tree came. What is the reason? Right, this is the reason. See this one. Previous problem, this program, previous program, if you observe, previously unary tree coming, now binary tree coming. What is the reason? This is the reason for this. See the reason? Right? See this one. Here 2 function calls. Here 2 function calls are there. Right? Previous, right? Right. So, previous problem, this problem if you observe, previous one is unary tree, it is a binary tree. What is the reason? The reason why it is a binary tree, see 2 function calls. 2 function calls are there. Right, 2 function calls are there, that is the reason binary tree came. Suppose in the 3 function call, ternary tree will come. But in the previous problem, if you observe only 1 function call. See multiplication of m comma n, right? Next one, previous, before that, right, before that, factorial of, right, n. In both the previous 2 problem, right, fact calling fact, right, 1 time only. Mul calling mul 1 time only, but here Fibonacci of n calling Fibonacci of n minus 1, Fibonacci of n minus 2. 2 function call, binary tree came. If 3 function call, ternary tree came. If n function call, n array tree will come. That is the reason in the computer science we are studying trees chapter. From today onwards, if anyone asks you, why in computer science we are studying trees, what will you say? Why we are studying, as a CSE people, why we are studying trees in computer science? What is the reason? Every recursive program behavior you can write, right, in the form of a recursive tree. In the form of a tree, that is the reason for that. Why previously unary came, now binary came. Previously every function is calling 1 1 only, but here everyone calling 2 2. That is the reason binary tree came. What is the binary tree definition? In the given tree, every node contains maximum 2 children, that is called binary tree. Right, fine, you know this very well. See, so because of 2 function called binary, if I add one more, Fibonacci of n minus 3, ternary will come. Right, like that, it's okay. So Fibonacci of 6, this is the story which is going on inside. I am thinking that you are really comfortable. Let's see this one. Listen, let's see this one. Carefully listen this. So Fibonacci of 6 calling 5 and 4. 5 is calling 4 and 3, something like that. So it is a binary tree, that is okay. If you observe clearly, listen, if you observe clearly, 6 calling, see this one, 6 calling 5, 5 calling 4, 4 calling 3, 3 calling 2, 2 calling 1. Can you help, 6 calling 5, 4, 3 and so on. See this one, 6 to 1, 6 to 1. How many? I think 6 levels. So 6 level tree, left hand side. 6 level tree, left hand side. Someone asking, why is 6 level tree left side? What is the reason? Why is 6 level tree left side? Right? If you see the program, see this one, if you see the program, right? In the tree left one is nothing but in the program first one. I am repeating once again, in the recursive tree, right? Many function calls are there, assume that binary tree, two children are there. In the recursive tree, left side person is nothing but, right? Recursive tree left side is nothing but in the program first one. Recursive tree, right one is nothing but in the program last one. In the program first one, right, I think it is going to be left. Program last, which is going to be right. Please be careful. If at all one more is there, left is there, right is there, middle also there. This is going to be first one means left one. This is going to be last one means right one. Please be careful. What is the left one? Always minus 1, always decrementing by 1. It is always decrementing 2. You only say, if you always decrement 1, 1, 1, 1, 1, what is the answer? N level tree will come. You know very well. From the 100 rupees every day, 1 rupee going on. Right? To make it as very small, right? You have to repeat 100 times. Because every time 1, 1 going. So 6, 5, 4, 3, 2, 1. See. Right? I think it is going to be 6 is given. Fibonacci of 6. Right? Left tree contains 6 levels. Right? What is the answer? Always you are subtracting 2. If you want, you can check. 6 becomes 4. 4 becomes 2. 2 becomes 0. See this one. Every time 2 going. If you subtract every time from the n 2, n by 2 will come approximately. Minus 1 plus 1, don't bother. It is going to be n level. Fibonacci of n given, n level. Right? Fibonacci of 6 given, 6 level. Fibonacci of n given, right side is going to be n by 2. Right? That n by 2 may be 4. I think, can you help 6 by 2? What is the answer? 3. It may be 1 extra came because of 0. Even, depending upon even number, odd number, plus or minus 1 may increase, may decrease. Think about logic only. Can you help now? Left always decrementing by 1. Right? Always going by 1, by 1, by 1. What is the answer? N by 1. Always decrementing 2, 2, 2. What is the answer? N by 2. I think it's the correct time from today onwards. If anyone asks you, Fibonacci of n will generate, right? Binary tree, that is okay. Left levels, what is the answer? N levels. Right levels, n by 2. Left levels means what? In the program, first person. Right levels, in the program, last person. Right? Left is always decrementing, minus 1, minus 1, minus 1. What is the answer? N by 1. Always if you decrement, minus 2, minus 2, minus 2, what is the answer? N by 2. So this recursive tree left height is n, right height is going to be n by 2. Fibonacci of 6 means left is 6, so right is going to be 6 by 2 approximately. Minus 1 plus 1, don't bother, because depending upon even number, odd number, plus or minus 1 will happen. Right? Don't worry. Fine. I am thinking that you are really comfortable. If you are comfortable, see this one. If you are comfortable, one more small, it is a binary tree. Please be careful. Binary tree may be having some gaps also. Why? Binary tree may be having some gaps also. What is the reason? Binary tree means maximum 2 children, not 2 children. Maximum 2. Please be careful. Now one more interesting question is there. Let me say this one. Binary tree may contain gaps because, right, a tree is a binary tree if it contains maximum 2 children everywhere. Right? But try to remember, in the given binary tree, no gap at all. Everywhere 2 children, no gap at all. Then it is called complete binary tree. In the given binary tree, right, nowhere gap is there, right, that is called complete binary tree. In the binary tree, gaps may be there. In the complete binary tree, no gap. Name itself saying complete, right? Please be careful. Can you help me now? Fibonacci of 6 will generate how many level tree? Right? 6 level left side, 6 by 2 level right side. Means n level left side, n by 2 level right side. That is okay, right? Can you see, is it binary tree or complete binary tree? Only binary tree. Only binary tree, that is also fine now, right? That is also fine. Now see this one. See roughly now. Listen correctly. Interesting answer. Please see this. See the interesting answer. So this is called complete binary tree. No gap at all. Complete binary tree means no gap at all. Now see this one, it is a complete binary tree. Can you see in this complete binary tree how many levels are there? Level 1, level 2, level 3, level 4. This complete binary tree contain how many levels? 4 levels. Now see everyone. This complete binary tree contain 4 levels, right? Please remember, this complete binary tree contain 4 levels. Then total nodes, if you want, you can observe, right? Complete binary tree is this one, complete binary tree, right? If you want, I will write the name also. See this. If you want, I will write the names also. See this one, complete binary tree. Complete binary tree with 4 levels. With 4 levels. Total nodes is equal to. Complete binary tree with 4 levels. Total nodes is equal to. See the answer? 2 power 4 minus 1. This is the formula. Complete binary tree with 4 levels. Total nodes is equal to 2 power 4 minus 1. Can you say how many? 2 power 4 means 16 minus 1, 15. It is the 15. Let me check 15 there or not. See. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Right? Please be careful. Complete binary tree with 4 levels. Total nodes are 2 power 4 minus 1. Right? In the similar way, complete binary tree with 3 levels. Total nodes how many? 2 cube minus 1, which will goes to 8 minus 1, 7. Right? If you want, you can check. See 1, 2, 3, 4, 5, 6, 7. Please be careful. From today onwards, if anyone asks you, what is the meaning of binary tree? In the given tree, everyone contain maximum 2 children binary tree. In the given tree, everyone contain 2 children. Means no gap at all. No gap at all. Then it is going to be a right, complete binary tree. Complete binary tree means no, completely filled. Complete binary tree. Right? Few gaps may be there, binary tree. But one thing, more than 2 children, no one there. Maximum 2 children, everyone. You know these small thing. And one more. Right? Can you help me now? K level complete binary tree contain total nodes how many? 2 power k minus 1. Right? I am thinking that you are really comfortable. Now see the story now. You are really comfortable. Please see this one. Fibonacci of n generated. Fibonacci of n generated. Complete binary tree or binary tree? Fibonacci of n generated. Complete binary tree or binary tree? Binary tree. The reason is Fibonacci of n contain left n levels, right n by 2. What is the meaning? Few gaps there. See, right few gaps are there. Right, see this one. These are the gaps. Right, these are the gaps. Left is n levels, I am okay. But right is going to be n by 2. See, few gaps are there. Please be careful. Right? And one more. Fibonacci of n will generate binary tree, but not complete binary tree. Please be careful. If you are okay, now say this one. Now see everyone. Fibonacci of n contain how many level tree? Fibonacci of n will generate how many level tree? Left n levels, right n by 2, it's okay. But maximum levels you have to say. How many level tree? N level. N level tree you got. Right? Fibonacci of n generated. N level. Binary tree or complete binary tree? Right? Left n levels, right n by 2, it's okay. Maximum levels we are taking. Right? Can I help you now? Fibonacci of n generated. Right? How many level tree? N level. N level tree, it's okay. N level binary tree or complete binary tree? N level binary tree, but I am writing complete binary tree. Fibonacci of n generated, n level, actually binary tree, but I written complete binary tree. What is the meaning? Even though gaps there, assume no gaps there. Even though gaps are available, assume no gaps are there. Some people are asking, sir, how can you assume no gaps are there? Means am I taking less or more? More I am taking. Actually it is a binary tree. I am saying that it is a complete binary tree. Means the things which are not there, see something not there, I am imagining that they are available. So I am imagining more, that is called upper bound. I am finding upper bound. See left n, right n by 2. How can I find out the exact answer? Let's find out at least upper bound. Fibonacci of n contain left n levels, right n by 2. I will take n levels. Larger one I am taking, means something like upper bound. Larger one I am taking, but left is only n by 2 levels, right? How can you assume that? Right also n levels, means something extra I am assuming, that is called as upper bound, right? I am finding upper bound. I am writing within the brackets also. Upper bound I am finding. Little bit extra I am adding, that is the reason. Upper bound I am finding. Can you help me now? Fibonacci of n contain n level complete binary tree. N level complete binary tree contain how many nodes? Right? 2 power n minus 1 nodes. 2 power n minus 1 nodes, right? 2 power n minus 1 plus 1, forget about. What is the answer? Order of 2 power n. Try to remember, time complexity of the recursive program is based on number of function calls. Time complexity of the recursive program based on, right? I am not saying that the rough diagram I am giving. Actual procedure afterwards there, you don't worry. Roughly I am giving. As of now, whatever possible I am saying. From this, please take positive things. Recursive program time complex, how to find out roughly. Using common sense, how can you find out recursive program time complexity? Roughly I am explaining. Afterwards, standard procedure is there. Again and again I am saying to you. Now can you help me now? Recursive program time complexity based on number of function call. Please help me. Fibonacci of n contain how many function call? Right? Most probably 2 power n function calls. Every one. Now what is the answer? 2 power n minus 1. These many nodes are there. Every node is a function call. See, every node is a function call. Fibonacci of n contain n level complete binary tree. Actually left n, right n by 2. Upper bound I am taken n level. Actually binary tree I took complete binary tree, right? Because it is not possible, so I took upper bound. Next one, right? N level complete binary tree contain 2 power n minus 1 nodes. Few may be extra. That is the reason upper bound. Next one, right? 2 power n minus 1 nodes. Forget about minus. Every node is a function call. Forget about minus 1 plus 1. Right? Big O of 2 power n. This is the time complexity. Fibonacci of n time complexity is this. Right? Big O of 2 power n. This is the Fibonacci of n time complexity. Now some people are asking, sir, why you written this diagram to explain time complexity? Now from today onwards, if anyone asks you Fibonacci of n time complexity how much, what will you say? Big O of 2 power n. Big O. Why big O? Big O means upper bound or lower bound? You know very well. Big O means upper bound. Right? Comparing the actual answer, actual time complexity of Fibonacci of n is not this much. Right? Big O of 2 power n. What is the meaning? Upper bound is 2 power n. Actual answer is less than or equal to 2 power n. Less than 2 power n actual answer, you know very well. Because right side so many gaps are there. No gap at all, then 2 power n. But right side few gaps are there. So I don't know how to find out exact answer. I think now students got the clarity. Why? What is the reason? Right? Most of the time finding exact answer is not possible. Most of the time. Right? As a human, most of the time giving exact answer may not be possible. So you may find out upper bound. You may find out lower bound. Suppose if at all your parents will ask you, when will you settle down in your life? Suppose if at all your parents are asking, right, until now you are studying, right, can you help me, can you please say to us, when will you get a job? Your parents are asking, until now you studied, but please let us know when will you get a job. What will you say? You cannot say, right, I will get the job 2022, right, month is, right, 5th month, right, day is going to be 22, time is going to be 5 o'clock. You cannot say like that. Right? If at all your parents are torturing you saying that, when will you get the job, because you are studying from the last 20 years or 21 years, when they are torturing like that, right, you cannot say exact thing. Right? 2022, 5th month, right, 5 o'clock, 5th month, right, date is going to be 22, right, so 5 o'clock I will get the job. There is no meaning of saying like that. So instead of doing that, you can just give upper bound. What is that? In 2023, maybe I will get job in 2022, upper bound. Mostly I will get the maximum 2023. Maximum 2023. Minimum means lower bound, something like lower bound. Minimum 2021. That is the reason. So I think from now onwards I am asking you, why people are going for upper bound, lower bound? What is the answer? Every time giving exact answer not possible. Every time exact answer, who will give? You are not God, I am not God. Who will give every time exact answer? So then what will you do? At the time when you cannot give exact answer, right? Instead of saying lie, exact answer you cannot give. If you don't say anything, people think that you are a dump. Your parents are keep on asking you, when will you get the job? You are not responding at all. Your mama will throw something on your face, confirm. Your papa is in his hand something there. He will throw on your face because you are not responding. They are asking, when will you get the job? You are not responding at all. Your mama shouting, your papa shouting, everyone doing like that. Right? You are not responding. Right? Then, right, instead of not responding, what is the best idea? Give upper bound or give lower bound. right? So upper bound means what? Maximum before 2023 I will get. Maximum before 2023 I will get. Next one, minimum, right? 2021 minimum I will get, something like that. That is the reason. Can you say from now onwards I am asking you, Fibonacci series, time complexity, what is the answer? Left is n levels, right is n by 2. Not both the side n levels, left n, right n by 2. So I don't know how to solve this one, left n, right n by 2. If at all both the sides same height there, both the sides same height, like complete binary tree, there is a formula. Complete binary tree having formula, other trees don't have formula because few gaps are there. In other trees few gaps may be there, but in the complete binary tree no gap. Whenever no gap is there, one nice diagram will come, definitely formula possible. Only for nice diagrams formula there. For normal, so a tree which contain many holes, right? You cannot give formula. Complete binary tree having formula, other trees don't have formula. So your diagram is complete binary tree or binary tree? Only binary tree. It is only binary tree, but complete binary tree only having formula. Then what will you do? These gaps whichever they see, many gaps are there. Those gaps assume that no gap is there. So it became upper bound. Fibonacci of n generating n level complete binary tree, which is the upper bound. So n level complete binary tree contain 2 power n minus 1 nodes, which is nothing but order of 2 power n. So time complexity of Fibonacci of n, what is the answer? Upper bound 2 power n, but actual answer is less than 2 power n only. Actual answer is less than 2 power n. I don't know how much, but less than 2 power n. Because of I don't know actual answer, I give an upper bound, right? Big O of 2 power n. And one more, time complexity of Fibonacci. Time complexity of Fibonacci, order of 2 power n, that is fine. It is everyone know time complexity of recursive program is based on number of function calls. Roughly these many function calls are there. Next one, some students are asking, sir, in the previous problem time complexity n something like that came, why 2 power n came? Previous trees are unary trees, there is no 2 will come. Previous one if you observe, right, what is the answer? N level unary tree. What is the meaning of unary? Everywhere 1 1 1 1, n level unary. But here if you observe, what is the answer? N levels there, but everywhere if you observe, first level 2 people, next level 4 people. So first level 1 person, second level 2 people, next level 4 people, like that some series going on. If you solve that series, you will get 2 power n. I am thinking that almost you are comfortable. It is the correct time to ask you. Please help me now. Please help me now. This recursive program, whatever you are studying, this recursive program time, what is the answer? This recursive program time is going to be upper bound order of 2 power n. Right? This is the time. Next, one more interesting answer. What about space? This recursive program, what is the space? Right? Let me check. Recursive program space complexity. Input plus extra. Input plus extra. Can you say what is the input? Fibonacci of n, 2 bytes. What is the extra? Everyone know. What is the extra? Everyone know. Recursive program extra space is based on. In the recursive tree, how many levels there? In this recursive tree, how many levels there? In this recursive tree, how many levels there? What are the answer? How many levels? I think n level this side, n by 2. Maximum how many? N level. Right? I think everyone know. Right, stack space, extra stack space is nothing but maximum how much space you want. What is the answer? N level tree, so n bytes. Right, I'm thinking, see this one, 2 power n function calls are there, but right, stack space required n only. Recursive program stack space, right, extra stack space based on, recursive program stack space based on number of levels, not number of function call, number of levels. So n byte, overall if you observe, big O of n. Right, this is going to be, some people are asking, sir, how n bytes? What is the answer? So recursive program stack space is based on number of levels in the recursive tree. But recursive program time complexity based on number of function calls. Number of function calls are huge. See, big tree came, 2 power n. Now I'm stopping, I want to ask you, can you help me now? What is the problem? Anyone having small disturbance also? Let me give conclusions now. Can you help me now? What is our goal? Fibonacci of n, right? Fibonacci of n to find out. You should write the recursive program and recurrence relation. We written recursive program and recurrence relation. Next one, right? This recursive program, time complex how much, space complex how much, right? For that purpose, I took one diagram. Time complexity, space complexity, explanation purpose, I took one diagram. After taking that diagram, I got to know Fibonacci of 6 means, right? If I draw the diagram, left hand side is 6 levels, right is going to be 6 by 2, because left always subtracting 1, 1, 1, 1, right always subtracting 2, 2, 2, left n levels, right n by 2, right? So it is a binary tree, it is not a complete binary tree, because right side so many gaps are there. And one more, it is a binary tree, but it is not a complete binary tree, few gaps are there, but everyone now, only complete binary tree having formula. Normal trees, every tree cannot have formula. There is no meaning in that. Everyone, right? How everyone can enjoy in the life. Some people will enjoy, some people don't enjoy, right? Similar way, right? Every tree cannot having formula, but complete binary tree having formula. Right? K level complete binary tree contain 2 power k minus 1 nodes. Please be careful. It is a binary tree, formula not there. Complete binary tree have a formula. So what I will do is, even though binary tree, assume complete binary tree. Means even though gaps there, assume no gaps are there. What is the meaning? You are adding extra. You are adding extra means upper bound. After finding upper bound, I got to know that this recursive program contains 2 power n function call, because every node is a function call. 2 power n function call. So time complexity based on approximately number of function calls. So time complexity order of 2 power n. Next one, recursive program stack space is based on number of levels, not right? Number of levels, not number of function call. Please be careful. Number of function calls are 2 power n, but number of levels are n. So time complexity 2 power n, right? Space is going to be big O of n, because right extra space is based on number of levels, n levels are there. So this is the time and space. Totally, I want to say to you 3 things I done in this problem. Right? For the Fibonacci of n, writing the recursive program, writing the recurrence relation. Next one, analyzing this program. Analyzing means finding time complexity, space complexity. Fibonacci of n time complexity. Carefully listen. Fibonacci of n time complexity, assume that Tn. Fibonacci of n, see this one. Fibonacci of n, actual time, assume that Tn. Fibonacci of n actual time is Tn. Actual time is Tn. Can you help me now? Fibonacci of n actual time is Tn, I am okay, right? If the Fibonacci of n actual time is Tn, right? Now can you help me? What is the 2 power n? 2 power n is a exact answer or upper bound? Comparing actual answer, 2 power n is bigger. Actual answer is Tn. Comparing actual answer, 2 power n is bigger. So upper bound, what is there in that? And one more, in this tree, left how many levels? N levels. Right how many levels? N by 2. N by 2. So this side some people not there, right? Left height is n, right height is n by 2. Right? This side some people not there, assume that there. That is called as upper bound. But see the interesting answer. Left is n level, right is n by 2. Means which side is more level? Left side. Right side less levels. Right is stopped here only. Let me take another color. See this one. Left is n level, right is n by 2. See, right is stopped here only. But left is going so many levels. So let us assume that he stopped here, but he is going further. Assume that here itself both are stopped. He is saying that still some more people are there, but he is saying that wherever I stopped, you also stop. What is the meaning? Right? Left is n levels, right n by 2. Right is n by 2. Right hand side person saying that wherever I stopped, you also stop. Means you are cutting some things or not. You are throwing something. What is the meaning? Even though some people available, you are not counting them. That is called something you are leaving. Means less you are taking. That is called lower bound. Can you help me now? Comparing actual answer Tn, 2 power n is bigger. Right? Suppose assume that left n levels, right n by 2. Right? If I take only n by 2, you only say n by 2 level complete binary tree contain how many nodes? 2 power n by 2. N level complete binary tree contain 2 power n nodes. N by 2 level complete binary tree contain 2 power n by 2. Right? 2 power n by 2 is the smaller one, less one. This is called as lower bound. Comparing Tn, 2 power n by 2 is going to be less. Comparing Tn, 2 power n is bigger. So this is going to be lower bound. This is going to be upper bound. This is going to be actual. From today onwards, if anyone asks you, Fibonacci of n time complexity Tn, how much? Fibonacci of n time complexity Tn, right? How much? What is the Tn exact answer? What will you say? Fibonacci of time complexity, if at all Tn, what is the Tn actual answer? What you are going to say? What will you say at that time? What will you say at the time is exact answer is Tn, it's okay, but I cannot find out exact answer because diagram is looking dangerous because left is n levels, right, n by 2. right? Diagram is looking very dangerous. So diagram is, if you want, I will show the diagram. So this is the actual diagram looking. See this one, actual diagram looking like this one. Left is that much, right is this, right? Remaining like this, some zigzag diagram like this. This is the Fibonacci of n, actual time complexity Tn this much. Left more, right less, remaining people are in between. So it is the Fibonacci of n actual answer. This is Tn. Please be careful. This is Tn. This blue color, sorry, this green color, whatever I written, that is Tn. If you count only this, it is the Tn. Right? This is the Tn, please be careful. Now see the answer, what I will do. What I will do is, I will add little bit extra like this. Something extra I will add. Even though not there, something extra I will add. So, then I think the more levels, complete binary tree I made. Something extra I added. This is called 2 power n. This is the upper bound. Only this green color only if you count, that is the Tn. Right? So, after adding extra if you count, that is your 2 power n, the upper bound. Now, supposing that I cut here itself. That is called as 2 power n by 2. 2 power n by 2 smaller, 2 power n is bigger, Tn is middle. So, if I want, I can write like this one. Actual answer Tn, comparing this, 2 power n is bigger. Comparing this, 2 power n by 2 is smaller. So, comparing Tn, 2 power n by 2 smaller means lower bound. Comparing Tn, 2 power n is bigger means upper bound. From today onwards, if anyone asks you, recursive program, Fibonacci given, this program given. Please listen, this is the conclusion. In one of the GATE examination, this problem is given, what answer you are going to give? Let me check. This program is given in one of the GATE exam. They are asking, this program time complexity Tn. This program time complexity Tn. Then what is Tn? Option A, big O of 2 power n. What is the meaning? Left hand side is the Tn there. What is Tn? Option A, big O of 2 power n. What is the meaning? Tn is big O of 2 power n. True. Option B, omega of 2 power n. False. Lower bound is not 2 power n. Upper bound only 2 power n. Right? Option C, theta of 2 power n. What is the meaning? Both upper bound, lower bound is 2 power n. No. Answer is upper bound 2 power n. Right? Supposition that upper bound not there. Lower bound 2 power n. No. Lower bound 2 power n by 2. Some people are asking, sir, how I know upper bound lower? Big O upper bound. Omega lower bound. Theta means both upper bound, lower bound, same, something like that. Can you help me now? To this problem, what is the answer? Tn is big O of 2 power n, right. Tn is omega of 2 power n by 2, that is also right. Right, lower bound is 2 power n by 2 omega, that is also right. Right, option C, A and B, that is also right. Right, whatever way they want, they can give. Can you say from this problem, I am really saying to you, it is a nice problem, that is the reason it is taken a lot of time. From this problem, you can learn many things. Now I given one example to you. Time complexity 2 power n, how it look like. See, one big binary tree came. Because the binary tree 2 power n came. If it is a ternary tree there, it could have been 3 power n. Right? Please be careful. So from this problem, you have to learn few things. What is the first one? Fibonacci of n. Right? Fibonacci of n, what exactly? So this table, please be careful. Fibonacci of n, actually what is the Fibonacci of n? Be comfortable with the table. If you are okay with this table, right? From this table, how to find out Fibonacci of n? Fibonacci of previous two things. In the similar ways, to remember properly, Fibonacci soup also I explained to you. Yesterday's soup plus day before yesterday's soup. Because of example, you are okay, write the program. Program also okay, write the recurrence relation. Because the program and recurrence relation you written. To this recursive program, how to find out time complexity? Time complexity approximately based on number of function calls, right? Like this. Right, space is based on, right, number of levels are n, maximum, right? So n level. So if you see time complexity 2 power n, space is going to be n level, tree required, so n by, so big O of n. It is a nice problem, please take care. If anyone thinking that, sir, I have small doubts, that's what you study in further classes. Try to get as much as possible. Some students are asking, in this problem, why I am unable to find out exact time complexity? Not possible. Whenever it is not possible, instead of doing research and all, what is the best idea? Give upper bound or lower bound. Your parents are asking, when will you get the job? Instead of saying, right? Instead of keep quiet, right? Instead of saying lies, what is the better idea? Give upper bound. Maximum 2000, before 2023, I will get. Minimum, they will ask you one more line also, minimum when, right? Minimum is, right, before 2021. Sorry, minimum is after 2021, like that. When you are unable to give exact answer, instead of sitting idle, instead of crying, best idea, give either upper bound or lower bound. That's what we will study in algorithm subject. Right, the nice debate happened, please take care. Those people who got this entire story, in algorithm subject, major part is this only, you concluded, right? Fine. Right, let's see the next problem. Until now, 3 recursive programs I explained to you. In every problem, something different, right? See, this is the place where experience will come into the picture, right? If I don't have any experience, all recursive programs at a time I will say. In one problem only everything I will say, some people will die also. Some people will cry, right? And that's the reason in every problem few things I am keeping. Right? Please be careful. After completion of all these 4, this is the last problem for recursion, right? This also please be comfortable. These are the, try to remember, these are the basics of divide and conquer. Total divide and conquer is recursion. Total dynamic programming is recursion. You don't worry at all. This is the starting of the recursion. I don't want to confuse you, so I am giving small examples. Correct place, right? I will explain A to Z. At the end of the algorithm, you will feel that you are comfortable, right? You are comfortable. Let's see the last problem for the recurrence relation and recursive program. See this. Write a recursive program and recurrence relation to find GCD of m comma n, where m comma n greater than or equal to 1. Right? For this one, we have to do that. Let me explain this. Everyone know greatest common divisor. Everyone know this. See this. Let me explain the problem first. If you are okay with the problem, then we will see the algorithm, what is the logic we can write and all the things. Right? Let's see this one. Can you help me now? You only say what is the GCD of? You only say 20, 30. Greatest common divisor. Right? The number which will divide both. Can you say what are the numbers dividing both? 20, 30. What are the numbers dividing both? What is the answer? I think 2 divides both. 3 no. 3 don't divide this, but it will divide. 3 no. Common divisor required. 4 no. 5 yes. 5 4s 5 6. Next one I think 2 also. 5 also. Next one is going to be I think 10. So next one is going to be 20. No. Right. I think the greatest number which can divide both is going to be 10. You know this very well. 10 is the one which will divide both, right? And bigger also. I think 5 also, but it is less than 10. 2 also, but the greatest common divisor is 10, everyone know. Next one, see this one, see everyone. GCD of, you only say GCD of 5 comma 7. GCD of 5 comma 7. What is the answer? GCD of 5 comma 7 if you observe. So what is the answer? Because of these are prime numbers, I think 1 and themselves, 1 is the answer. Correct? Because 5 divides only 5 but not 7. 7 divides only 7 but not 5. So 1 divides both. The greatest common divisor for these 2 is going to be 1. That is also okay. Right? I am thinking that you are really comfortable. Now see this. Now see this one. What is the answer? See, be comfortable this also. What is the GCD of 0 comma 5? GCD of 0 comma 5. Some people are asking, sir, mn greater than or equal to 1. Mn greater than or equal to 1. From where you will get the 0? Some people are asking, right? So I am not giving 0, but whenever this recursive procedure is going on, in the middle may come 0. Please be careful. In the middle there may be a chance. Starting 0 is not there because mn greater than or equal to 1. In the middle 0 may come. Right? That is the reason I am talking. GCD of 0 comma 5. Can you help me now? What is the greatest number can divide both? What is the greatest number can divide both? Right? Let me check here. Right? Is 1 dividing 0 or not? If you want, you can check. 1 divide 0 or not? See this one. 1 0 0. Yes. 1 divide 0. 1 divide 5 also. 1 divide 0. 1 divide 5 also. Next one. What about 2? 2 divide 0 but not 5. So like that 5 divide 0, 5 divide 5 also. Greatest number which can divide both is 5. Right? Now see the next one. One more example. See this also. GCD of 5 comma 0. What is the answer? The greatest number which can divide both is 5. Next one. What is the answer? GCD of 0 comma 0. What is the greatest number can divide both? I think 1 can divide, 2 can divide, 3 can divide and so on. Greatest number which can divide both is infinite. Indication that GCD is not possible GCD definition, GCD is not defined, right? If both the numbers are zeros, undefined, GCD is undefined for this, right? I think this is the GCD. Little bit rough diagram I explained. Now can you help me one small line now, right? What is the GCD of m comma n if m 0? GCD of m comma n if m 0. If m 0, answer is n. GCD of m comma n, what is the answer? If n 0, answer is m. If both 0, GCD is not defined. Both 0, it is not possible at all, because see this one, m comma n greater than or equal to 1. I will give initially non-zeros whenever it is going on, right? In between maybe one person may become 0, both cannot be 0. That is the reason this case not possible. GCD is undefined, right, if both are zeros. Can you say what is the GCD termination? GCD of m comma n, answer is m if n is 0. Answer is n if m is 0. Answer is m if n is 0. Right? This is the GCD termination. Both 0 not possible. You know very well. Right? Now let's see the major logic. Let's see the major logic. Right? How to find out GCD if both are non-zeros? That is the major one. I am trying this. Please listen. One interesting story. And one more. Many ways may be there to find out GCD. Many ways are there. One way I am giving. One way. Right? One way I am giving. That way only I will find out the time and space also. One way only. Whatever logic I am thinking, that one I will explain to you. Right? After explanation is over, if you are okay, I will write the recursive program, recurrence relation. So let me start this. Let me start. See everyone now. GCD of. Make sure that everyone listen. GCD of 5 and 8. GCD of 5 and 8. What is the answer? I have to find out. Let's see. This is the procedure. If you want to find out GCD of 5 comma 8, this is the procedure. See this one. 5, 8. 5 ones 5. What is the remainder? 3. So see this next one. GCD of, right? Whichever is a remainder, keep in the first place. With which number you divided, keep in the second place. Right? Like this. Just divide with the remainder. Next story. Repetitive division, divide like this. GCD of 3 comma 5. GCD of 5 comma 8. 5 will come here, 8 will come here. Just do remainder. Right? This will go here, this will go like that. Now if you are okay, this is the thing which is going on. This is the thing which is going. What is the meaning of recursion? Same thing you repeat. Let me repeat same thing. Same thing I am repeating now. See this one. 3, 5. Same thing I am repeating. See this one. 3, 5. 3 1 is 3, remainder 2. What is the next function called? GCD of 2 comma 3. Next one, same thing again. 2, 3. 2, 1, 2. Remainder 1. Next one, GCD of 1 comma 2. Next one, 1 and 2. 1, 2 is 2. Remainder 0. What is the next one? GCD of 0 comma 1. Right? So you know very well. GCD termination. If any one 0, next person is the answer. If you want, you can check for these two numbers. What are the two numbers? GCD of 5, 8. GCD of 5. The greatest number which can divide both is 1. This is the answer. Continue the same procedure until 1 will come. Until 1 will come. Repetitive division. Dividing, always with remainder, divide. With remainder, divide, and so on. Now some people are asking, sir, can you give one more example? I am giving one more example. See this? I am giving one more example. See everyone now. GCD of 10,000, 50,000. Right? I am finding. See this one. GCD of 10,000, 50,000. First one take here, second one here. I think what is the answer? 5 times. It became 50,000. It is 0. Right? What is the next one? GCD of 0 comma 10,000. Everyone know. One person is 0, next person is the answer. Answer is 10,000. Answer is 10,000. I am thinking that you are okay with the second example also. See the third example. See this also. See the third example. GCD of. Make sure that this also you listen. GCD of 53, 17. GCD of 53 comma 17. Right? Let's see this. Same way. First one, first place, second one here. Can you help me? Will it go at least one time? No. 53 zeros, 0. Remainder 17. Next one, GCD of 17 comma 53. Again same. 17, 53. So 17 3s, what is the answer? 51. 51, remainder 2. Next one, GCD of 2 comma 17. What will happen now? 2 17. 2 8 16. Remainder 1. Next one, GCD of 1 comma 2. Same. 1 is here, 2 is here. 1 2 is 2. Remainder 0. Next one, GCD of 0 comma 1. Right? Answer is 1. Right? Like that. This is the way how to compute the GCD. Right? So I explained to you initially what is the meaning of GCD. I given 3 examples how to compute GCD. What is the GCD I explained. Next one is how to compute GCD. I done that. There may be some other way. One approach I am giving. Repetitive division. Divide with remainder, divide with remainder, divide and so on. Right? This is going on like this. If you are really comfortable with all these examples, let me write the program. Let me write the program. Many people see I'm saying one small line to you, right? As a computer science person, you know algorithm subject very well. You may know some randomly. Few things in every topic, few things you know. If I take any topic, time complexity, previously you know 70%. After my explanation and everything is over, you may got 90%. Correct? If you repeat 1 or 2 times, you may get 95%. If you practice some more problem, it will become 99. Like the day to day, you have to keep on improve. Every day you have to keep on improve. Recursive program, recursion. What is the recursion? In the factorial program, first one, I explained what is the recursion. While recursion is going on, what actually happening, right? Roughly I given. Time complex, I didn't concentrate that much. Little roughly is, right? Little roughly time and space I explained. In the next problem, time and space little bit, right? Deep I explained. Third problem more deep, right? Like that. In every problem something will be there, right? After listening all the things, you will get the full clarity. Right? This also you listen, right? I think GCD, 3 examples also I given. Based on that I am writing the program. See the program? GCD of m comma n. Can you help me know what is the termination? Both are non-zeros. What is the termination? See this one. If m is equal to 0, what is the answer? Return n. One more. If suppose it is true, then you will go. It is failed, then only you will come. See, if it is true, you will return. If it is true, you will return. You will return means what? You will go out of this function. If the first one is true, you will return. You don't go further. You will return means you will go out of this function. First one failed, then only you will come to second one. See, if n is equal to 0, then return m. Right, like that. So, first one failed, then only second one failed, then only further. This is the if condition. Because of GCD having 2 termination, I written 2 ifs. Right? Let's see the next one, else. So, these two fail, then you will come to the else part. What is the else part? If you come to the else part means, right? No one is 0. Suppose assume that, you only say, assume that this is 55. This is 100, assume. This is a 55, this is a 100. Then, what is the else part? What is the answer? I think you have to apply GCD again. GCD of. Can you say what is the first person? Remainder. What is the meaning of, what is the remainder here? If you divide, right, 100 with 55. What is the answer? N modulo m. Like this. The meaning of this one is going to be, right? With 55 you are dividing 100. Check. With 55 you are dividing 100. Whatever remainder will come, that is. Next one. Here, what is the answer? With which number you divided? 55, which is going to be m. Just do that like that. Everyone, what is the meaning of recursion? Right? So bigger problem becomes smaller problem. You will call this same thing, right? These people will go once again here. They will keep on repeat. Until any one of the case will happen, m0 or n0. Right? So after completion of all, return the answer. Return. Right? End of the else. Please check 3 examples I explained. Any small doubt also there, please go through it. Same thing. Examples you are okay, means program also you are okay. If m0 return n, n0 return m, If both fail, then come here. GCD of n modulo m. What is the meaning of n modulo m? If you divide n by m, whatever remainder is there, and with which number you divide with m. Same story will repeat again and again. Right? Fine. That is the GCD. Right? That is the GCD program. Now, if you want recurrence relation also, you can write. It is the recursive program. It is the recurrence relation. It is the recurrence relation. See this one? GCD of m comma n is equal to, you only say, what is the answer? Answer is m if n 0. Answer is n if m 0. Otherwise, GCD of n modulo m comma m if m comma n greater than 0. Right, like this. Same thing I written. Fine. I am thinking that you are really comfortable. Now please help me. Please help me. See this program and talk. And one more. Right. See this program and talk. It's okay. Now let me ask you one simple line. GCD program generating. Because of the recursive program. GCD program generating binary tree or ternary tree. Every recursive program will generate the tree. You also know, I also know. GCD program generating binary tree or ternary tree. What is the answer? GCD program generating not binary, not ternary, unary. It is generating unary. If anyone having small doubt also, sir, how unary? See this one, it is unary tree. See the function call to function call, right? Unary tree. There is no two function call, unary tree is going on. See this one. Function calls only. A function calling that itself. Unary tree. This is also unary tree. Right? Please be careful. So GCD function, GCD program, whatever, GCD logic, whatever we explained, whatever program we written, right? It is generating unary tree. Please be careful. Right? Unary tree. Next one. That is okay. That is okay. Can you help me? What is the GCD time complexity? GCD time complexity mostly depending upon number of function calls. GCD time complexity, right? Mostly depending upon number of function call. But you know very well what is the actual procedure. One standard procedure is there. Afterwards it will come. Nice procedure will come. But to say that some basics required. That is the reason I am controlling. Within few minutes that will also come. But these four examples, whatever I explained until now, including this, right? They will give some idea. Right? They will give some idea. If you do further stories also like this, it will take a lot of time. That is the reason one standard procedure is there. Right? If you do like that, drawing the diagram, right, analyze, it will take a lot of time. But there is one nice procedure afterwards you will see. Right? Can you help me now? So this recursive program time complexity how much? Roughly let me explain. This recursive program time complexity how much is, right? It is unary tree, that is also okay. It is unary tree, that is also okay, right? This recursive program time complexity, if you observe clearly, you are keep on dividing. If you keep on divide, mostly it will goes to log n time complexity. Some people are asking, so you only say, if you always divide by 2, right? If you always divide by 2, log n base 2. If you divide always by 3, log n base 3. But you are keep on dividing by different number. So that is the reason log n base 2, log n base 3 differ by constant only. You know very well. Both are asymptotically equal. Log n base 2 is theta of log n base 3. Both are asymptotically equal. Base 2, base 3, base doesn't matter. Because all are differ by, right, constant factor. So all are asymptotically equal. It is the correct time to ask you, right? What is the GCD of m comma n time complexity? What is the answer? Answer is log n. So why log n? Comparing m and n, whichever is bigger, log of that. Comparing m and n, whichever is bigger, right? Log of that. Base 2, base 3, whatever you want, you can keep, no objection at all. Because all differ by small constant. Let's check if you want. If you want, you can check. Can you help me one small? See this problem. See this problem. Right? 5 and 8. GCD of 5 comma 8. What is the bigger number? Bigger number. What is the bigger number? 8. Bigger number 8. What is the log 8 base 2? What is the answer? 3. 1, 2, 3. Actually 3 function call, right? It became 3 plus 2 maybe. Otherwise 2 into 3 maybe. Right? Otherwise 2 into 3 maybe, 3 plus 2 maybe. But one thing I want to say to you. Listen, I think it's the correct time. If anyone having small doubt also, I am saying now. GCD of m comma n time complexity where n is bigger. What is the answer? Answer is not log n. Answer is, right, order of log n or theta of log n. Means asymptotically log n. Some constant factor log n. That may be 10 log n. that may be 5 log n, that may be log n by 2, that may be log n plus 2, but one thing in terms of log n. Again I am asking you GCD of m comma n time complexity where n is bigger. What is the answer? Because of always you are dividing, right, log will come. This is the only thing I am saying, always you are dividing, log will come. If you do always minus 2, n by 2 will come. In the previous problem, always minus 2, n by 2. Here always dividing, log will come. Which base? Take whatever base you want, all differ by small constant only. So, what is the answer for this one? Log 8 base 2. If at all log 8 base 2, 3 came, some people are saying 5 came, then what is the answer? Maybe 2 into log. That is the reason I am saying theta of log n means constant factor of log n. Please be careful. Why log is came? Always you are dividing. That is the reason for that. I am thinking you are okay now. So, let us see this one. This program time complex, I am writing here. This program time complexity. This program time complexity, this one, this program. GCD of m comma n, this program time complexity is going to be, right, let me write now. Order of log. Base whatever you want you can write. Where comparing m and n, right, m is less than n. Because of always you are dividing. Log n will come. Right, it may be 2 log n, it may be 3 log n, right, order of log n, please be careful. I am thinking that you are little bit fine now, right, let us come to the next one. See the interesting answer. So, those people who are, if anyone having small doubt also, I took one more example also, see this, I took one more example also, roughly like that, 53, 17, bigger number 53, can you help me now, log 53 base 2, log 53, I think this 53 can be written as closest powers of 2, what is the answer? 2 power 5, 32, 2 power 6, 64, close is I think 2 power 6, I think log 2 power 6 base 2, what is the answer? 6 will come, let's check, 6 is coming on 1, 2, 3, until now 3, 4, 5, see, closely like that, log n minus 1, log n plus 1, right, that is the reason I am saying to you, right, big O of log n. Forget about minus 1 plus 1, I am really saying to you, algorithm subject you cannot learn, if you keep on substituting numbers. Think about logics only. That is the meaning of asymptotic notation. Asymptotic notation simply saying that don't think about small thing. Don't think about constant, think about logics. Use brain, right? Logic only. Some people are asking what is the logic here? Always you are dividing. Dividing may be different number, but always you are dividing. Because of always dividing, log will come. If you keep on substituting small number, minus 1 less, plus 1 extra, plus 10 extra, if you keep on thinking, this subject not possible at all. I also, whenever initial days of, whenever I am learning algorithm subject, right, so I am really worried about small constant, then it really troubled me because sometimes it don't work, because in algorithm terminology, in asymptotic notation, 10 is equal to 100. In asymptotic notation, every constant is theta of 1. If every constant is theta of 1, what is the meaning? All constants are equal. That is the reason, don't bother about small thing. Think about what logic going on. What is the logic here? Always divide. Log n will come. Whichever is larger number, log of that. Forget about minus 1 plus 1 because it is big O of log n. It is not log n, big O of log n. So, the time complexity of GCD of m comma n is going to be what is the answer? Order of log n, that is okay. But see the one more interesting line. See the one nice logic is there. See this also. Can you help me now? 10,000, 50,000, big number. To this also I have to explain. 10,000, 50,000, who is the big number? 50,000. You only say. What is the log 50,000 base 2? 10,000, 50,000, bigger number is 50,000. What is the log 50,000 base 2? What is the answer? I think every one of these can be written as approximately 2 power 16. This can be written as 50,000 can be written as 2 power 16. Log 2 power 16 base 2. What is the answer? 16. Actually 16 should come. See, it is stopped immediately. Log, so GCD of 10,000, 50,000, answer is going to be 10,000, it's okay. Right? Immediately stopped. But actually how many function calls should come? Approximately 16 function calls should come. Right? Immediately stopped. Means what I want to say directly, GCD problem sometimes will stop immediately. GCD program, the logic whatever we written, GCD program will stop immediately sometime. Within less time program will stop. Right? That is called GCD best case. I given a big number. Some people are thinking that best case means small numbers you give. No. Best case or worst case or average case, that is decided by logic only. Small numbers don't give best case. Big numbers don't give worst case. Logic will give best case or worst case, average case. Logic only. Can help you now. When the GCD will give best case. What is the meaning of best case? The minimum amount of time required to solve the problem is known as best case. The minimum amount of time required to solve the problem is known as best case. Can you help me now? When the GCD will give best case, when the GCD program will stop immediately, right? If the given two numbers are multiples to each other, then GCD will stop immediately. You are given big number, small number doesn't matter. You are given two numbers which are multiples to each other, yes, then immediately remainder becomes 0, then GCD will give the answer. GCD will give best case time complexity if the given two numbers are multiples to each other. It is the correct time to ask you, GCD best case 1. 1 means what? Constant. What is the meaning? Immediately it will stop. GCD will stop immediately if the given two numbers are multiples to each other. That is the GCD best case. Now can you help some interesting answer? When the GCD will give worst case. When the GCD will give worst case is if the given two numbers are consecutive Fibonacci series. Consecutive Fibonacci numbers. If the given two numbers are consecutive Fibonacci numbers, then GCD will give maximum time. GCD worst case, given two numbers are consecutive Fibonacci numbers, then GCD will take more time. Given two numbers are multiples to each other, then GCD will take less time. Let's see this example. See this one, these are very small. 5 and 8 is very small, but what is the Fibonacci series? 0, 1, 1, 2, 3, 5, 8. See this one. Two consecutive Fibonacci numbers I given. GCD will take more time. See, if some people are asking how more time, log it base to 3, but see, more than 3 came. Lot of thing came. See this one, more than 3. It may be 2 log n. GCD will give worst case if the given two numbers are consecutive Fibonacci numbers. GCD will give best case means immediately will stop. Given two numbers are multiples to each other. This is going to be best case. This is going to be worst case. Right? Log n. Please be careful. Now I think I am explaining. Listen, I am explaining. Some people are asking consecutive two Fibonacci numbers. Worst case will come. Next one. Multiples to each other is given. Best case will come 1. It's okay. Then what about remaining? Right? Whatever you want. Try to remember. So this also looking like. This also looking like. Right? It is a very rare incident. Both will stop immediately. That case also there. That is the reason best case most of the time. Right? It will go like log n. Most of the time what is happening, that is called as average case. Most of the time GCD will behave like worst case only. It is a very rare incident. GCD will stop immediately. If the given two numbers are consecutive, right, given two numbers are multiples to each other, best case will come. I am okay. Right? Next one, consecutive Fibonacci numbers given, worst case will come, that is also okay. Remaining things will come. It is almost equal to log n only. Now let's see this. Let me give conclusion. Right? I think this is the program. Let me give conclusion. See this one. This program, whatever we explained until now, this program, assume that GCD of m comma time complexity, please listen, GCD of m comma n time complexity, assume that Tn. GCD of m comma n time complexity, assume that Tn, because the big number is n, I am taken Tn. GCD of m comma n time complexity Tn, listen, Tn is equal to, can you help me one small line now? What is the Tn maximum value? GCD of m comma n time complexity Tn, it's okay. You only say Tn, what is the maximum? Tn maximum will go to log n. Right? Maximum is log n. Tn maximum log n. Next one, can you help me now? What is the Tn minimum? Minimum is 1. This Tn is oscillating between these two people. Please be careful. At any cost, Tn cannot go more than log n. Tn sometimes log n. Tn sometimes 1. Tn is in between. It keep on oscillating. Sometimes 1, sometimes log n. It don't go more than log n. It don't go less than 1. These are the boundaries. These are the boundaries. If anyone asks you, time complexity of GCD of m comma n is Tn. Can you say the boundaries for Tn? What is the answer? Tn cannot go more than log n. Sometimes Tn is log n, but more than log n not possible. So big O of log n. Next one, sometimes Tn is 1, best case 1. So this is covering all the things. If I want to say in another way, I can say like this one. GCD algorithm, best case 1. I written best case 1. When you written best case, it doesn't matter which symbol and all. GCD algorithm, best case 1. Next one, worst case log n. Worst case log n. Right? Technical way of writing is like this. This is the technical way of writing. GCD time complexity, technical way. GCD time complexity Tn, it cannot go more than log n. Equal to log n also okay, but more than log n, no chance. Tn minimum is 1. Same thing you are saying here. Best case is this, worst case is this. Right? It is the normal way of saying, right? Technical way is like this. Please be careful. Try to follow technical way. Both are correct. These are normal English letters, right? English language you written. It is a asymptotic language you are using. This is the English language. This is a asymptotic notation. Right? Fine. Now listen. One interesting that I want to say to you. Please listen. Please listen now. Please listen. This will confuse you, right? But one interesting thing I want to say to you. Can you help me now? GCD time complexity. Carefully listen. It will really confuse you if you don't listen. GCD time complexity Tn assume. GCD time complexity Tn assume. Can you help me now? What is the Tn value sometimes? Log n. Sometimes 1. Tn value sometimes is log n, sometimes 1. But one thing, Tn don't go more than log n. Tn don't go less than 1. Right? Like that I written. Notation I written. Right? But see this one. See carefully. One thing is, in this problem, I can really say what is the Tn. In this problem, I can say what is the Tn. I can find out also. What is the reason? Tn is either log n or 1. What is there in that? In this problem, time complexity of this problem is Tn, that Tn is either log n or 1. I know very well. Only two possibilities, either log n or 1. Fine. But in the previous problem, if you observe, right, actual time complexity Tn, which we don't know. In the previous problem, actual time complexity Tn, which we don't know. So, upper bound I am taken. Upper bound is 2 power n. Lower bound I am taken 2 power n by 2. Previous problem Tn is actual, which we don't know. So, upper bound, lower bound I written. But here I know. Tn is either log n or 1. So, what I want to say, you can write upper bound, lower bound anywhere. You can write upper bound, lower bound anywhere. But one thing, meaning cannot change. Please be careful. Meaning cannot change. And one more. What is the meaning of worst case time complexity? Worst case time complexity, what is the meaning? Maximum amount of time you are taking. Best case time complexity, minimum amount of time you are taking. Can you say GCD program? I am repeating again. GCD problem, minimum time 1, maximum time log n. What is the actual time? The actual time is Tn, that will be either log n or 1. I know very well Tn, that is either 1 or log n. But in the previous problem, actually is Tn, which we don't know. But we can say boundaries. It don't go more than 2 power n. It don't go less than 2 power log n. 2 power n. Right? Like that. Right? Okay. Whatever you got, it's okay. In this problem, I want to introduce what is the best case time, what is the worst case time. Right? Please be careful. To introduce this only, I took this problem. What is the meaning of worst case time? The maximum amount of time to solve this problem. What is the best case time? What is the minimum amount of time to solve the problem? Can you say minimum means small numbers or big number? Minimum, maximum concept will come. Not small number, big number. Logic. What kind of inputs? What kind of inputs I should take? What is the size of? I'm not talking about the size. I'm talking about what kind of relation. What kind of inputs I should take so that best case will come. What kind of inputs I should take, worst case will come. It is something like quick sort. In further classes will come quick sort. If we give ascending order input, quick sort will give worst case time. If we give random order, quick sort will give best case. Depending upon what kind of input will come, what kind of input you will give. Based on that, best case, worst case will come. Best case not based on the small or big like that. Best case is based on, right? I think what kind of input I should give, this algorithm will give best case. You have to think like that. Can you say GCD best case? Two numbers are multiples to each other. If you give, best case will come. Worst case, right? Two consecutive Fibonacci number, worst case will come. If you give other than that, right? That is called as average, which is almost equal to worst case only. Right, which is almost equal to worst case. What is the, which average case is almost equal to worst case only here? What is the reason? Most of the time worst case behavior only coming. That is the meaning of average, means most of the time what is happening. In this problem I am introducing three keywords. Best case definition, minimum amount of time required to solve the problem. Worst case time, what is the maximum amount of time to solve the problem. Average, other than those two, is called as average. Average is nothing but most of the time what is happening. Most of the time worst case happening, then average is worst case. Most of the time best case happening, then average is best case. Please be careful. In GCD most of the time worst case happening, so average case becomes worst case. When worst case will come, right? Two consecutive Fibonacci numbers if you give worst case. When best case, right? If you give multiples to each other, best case. In this problem my goal is only this. In the previous problem my goal, introducing upper bound, lower bound. When will you introduce upper bound, lower bound? You know answer is Tn, but you cannot express. At least give upper bound, at least give lower bound. Right? Please be careful. Upper bound, lower bound can be used anywhere. Meaning without changing the meaning, use upper bound, lower bound anywhere. You know already answer, then also you can give upper bound. You don't know, then also you can give upper bound. Right? You can use whatever way you comfortable. Previously I don't know, I am using upper bound, lower bound. Now I know, I kept the boundaries. Anywhere you can use the big O notation, omega notation, theta notation without changing the meaning. Any small confusion, right? In further classes you will get to know. In the previous problem my goal upper bound, lower bound. Here worst case, best case, average case. Before the two problem introducing recursion. 4 problems I said very clearly. Please go through all of them.